Okay, hello everyone, it's Salar and we are in part 38 of our tutorial, a tutorial to writing a real-time operating system. Finally, in previous part, I developed a simple real-time operating system. And as I said in previous part, in this part, I wanted to start to develop and implement a real-time operating system with more options, okay? Now we want to start to implement and develop our RTOS and RTOS with more options and a more professional RTOS and a more practical RTOS. Okay, but before to start implementing this RTOS and RTOS with more options, we need to have some other materials to develop our operating system. Okay, to develop our RTOS, we need to some libraries and some other materials to use in RTOS. Okay, but one of the most important materials that we need to implement our RTOS is data structures. Okay, we need to have some data structures. But what is data structures? Some of you may know what is data structures because some of you are computer science students, and computer science students in bachelor degree have a course as a algorithm and data structures. Okay, and you may know what is data structures, but if you don't know what is data structures, no problem. I will give you some information and some implementation about some simple and advanced data structures before starting implementation of our real-time operating system. Okay, but what is data structures? As I said, a real-time operating system or operating system is a big program. Okay, and RTOS needs to store some data in memory, for example in SRAM, okay, or for example in your heap memory. And as you want to store these data in memory on a regular basis, we want to save and store our data in memory in a better ordering, because we have a lot of data in memory for operating system. Okay, and we need to have a regular basis, we need to have a better ordering. So it's recommended to use data structures to have better order. Use this data structures to have better order. But before talking about simple data structures, I recommend you to provide this textbook, Introduction to Algorithm. Okay, Introduction to Algorithms, 3rd edition or other editions. Okay, it's a very nice book for algorithm and data structures. Okay, and this book called CLRS and CLRS algorithm. Okay, and CLRS stands for name of others. Okay, I recommend you to it's recommended, it's not necessary, but I recommend you to provide this book and study that, because it's a very nice book about data structure and algorithms. Okay, and almost all of my data structures in this project developed according this book. Okay, so let's talk about first simple data structure that we need. Linked list. What is linked list? It's a simple data structure. A linked list is a data structure in which the nodes. What is nodes? Here is a list. Okay, I have 3 nodes in my list. A list created from nodes, for example node 1, node 2, node 3. Okay, in which the nodes are arranged in a linear order. Okay, a node, and after that another node, and after that another node, continuously in a linear order. But as I said, as you can see, here is linked list. Okay, a list that's linked to each other, nodes linked to each other. For example, here I have node 1. In node 1 I have element is a data that I want to use in memory. Okay, and in my node I have a pointer to next node. Another time I have a pointer to next node, but at the it's a last node and we don't have any node after that. Okay, so this node doesn't point to another node. Okay, so here is a linked list. Each node points to the next node. Okay, here is a simple linked list. So let's implement a simple linked list in C. I wanna create a linked list to save some 32 bits integer data in that 32-bit integer data as an element. So in my list, element is an integer. Okay, 32-bit integer. So first, to implement my list, I need first to implement my node. A node in my list is a structure. Okay, is a structure. Struct linked list node. Okay, in my struct I have elements. I have an element, integer, 32-bit integer, and a pointer star, a pointer to next node, to another linked list node similar to this linked list. Okay, so in each node I have an element and I have a pointer to next node. So I have an integer and pointer to next node. Okay, and I define the type from this struct linked list node underlined e. It's a type and I can use this type in my program. Okay, but after that I need to implement my list. Another time I've implemented my list as another struct, but in this time linked list. Okay, here is linked list node, a node of this list, but here is linked list. It's a structure that saves some data about list. For example, in my list I have size of my list. Okay, it's an integer number. For example, the size of my list is number of nodes that added to my list, and I have a nil node, a pointer to nil node. What's nil node? First node in the list. Okay, in this time my size is 1, 2, except of nil node. You don't calculate the nil node in your size of list. Okay, in the size of your list, this list has the size of this list has 2. In first node I have 5 as an element, and after that 13 as another element. But why we need to have nil node, a pointer to the first node, to a pointer to nil node of my list? That is the first node in my list. In the next part I will give you more information. I will give you more information about nil node. With this nil node we can implement our linked list easier. Okay, and it can makes us to implement our list easier. Okay, so in each list we have a nil node point to the first node, and this node point to another node after node, and this node is the last node in my list and doesn't point to another node in my list. Okay, so we need to do some operations in our list. One of that is insert a node in a list. Assume that in your list you have nil node, first node and last node, okay, 5 and 13, and you want to add another node to your list. You can add your node in the first of your list after nil node, okay. For example, you can put 10 in a node and put this node in a list in first of the list after nil node. But when you want to insert a node in the first of your list, you need to do some operations. First, now this node point to first node, this node, okay. What's the address of this node? The address of this node is here. Nil node point to the next node, to node 5. So now we need to that nil node dot next node, this pointer, okay, here. Now this node point to 5, okay. So new node, here is new node. Dot next node equal to nil node dot next node, and nil node must point to this node. Nil node dot next node is new node, and increase the size of your list. Let's to implement this list in and this operation in C in Eclipse. Okay, as you can see, here is my program. First, I have a linked list node. In each node I have an element, an integer number, and a pointer to next node, another similar node, okay. And I have a struct for list. In list I have a nil node and I have size of my list, and I have a function to insert a node in a list, okay. As you can see here, I have my function. As I said, you need to put nil node dot next node in node dot next node. After that, put the address of node in nil node dot next node, and after that size plus plus of list, okay, to increase the size of list. Add this node, add a node to a list and increase the size of list. So first, in my program, in my main function, I need to create a list. But before to creating a list, I need to create a nil node for my list, okay. First, create a nil node, allocate memory to this node by malloc function, okay. Allocate memory for nil node. The element of nil node is not important. For example, here 0, and next node of nil node is null. Next node of nil node is null because at the first we don't have any other nodes than nil node in the list, and nil node point to a null pointer. It means point to no other nodes, okay. And after that, create list, okay. And like node, allocate memory to list dot nil node must equal to nil node, okay. Here is nil node, and the size of list at the first is 0. So now I've created the list. As you can see, the size of list is 0 and nil node is here, nil node, okay. This address here is, I have my nil node in my list and the size is 0. So let's to create a node that its element is 13, okay. Another time, allocate to memory to node 1, element is 13. As you can see, node 1 element is 13, okay. And let's do insert this node to the list, okay. Insert first of the list after nil node. So insert that. Now, as you can see in the list, the size is 0. First, I have nil node. The element of nil node is 0, but the next node of nil node is node 13. Okay, note that its element is 13. Okay, after that, let's create another node. For example, node 2, that its element is 5. Create node 2 and insert that in the first of the list, after nil node, before node 13. Now, another time, as you can see in the list, the size is 2. First, I have nil node. The next node in this time, the next node of nil node is 5, not 13, but the next node of 5 is 13. And the next node of 13 is null, because 13 is the last node in the list. So first I have nil node, the next node is 5, and the next node is 13. Okay, in this way, easily you can add a node at the first of your list after nil node. Okay, let's go back to the slides. We can do another operation on this list, this linked list. It's delete from linked list. Delete, for example, first node in the list, first node after nil node. So when you want to delete this node, you need to say to the nil node to point to next node of this node. Okay, so when you want to delete this node, you just need to change this pointer. So nil node dot next node, this pointer is nil node dot next node dot next node, node 13. Okay, nil node dot next node equal to nil node next node and next node. In this time, nil node point to node 13 and size minus minus to increase the size of the list. So let's implement this operation in Eclipse. Okay, another time this program, but in this time I have another operation, another function, delete first from list. Okay, and if you want to delete first node after nil node, you need to change this pointer, next node of nil node, list nil node dot next node equal to list nil node next node and next node, and size minus minus. Another time, let's debug my project. Create nil node, create list, add node 13 at the first of list, add node 5 at the first of list, and now I want to delete first node, but as you saw in previous example, in list nil node, the size of list is 2. First I have nil node, after that next node of nil node is 5, and next node of 5 is 13. Okay, I want to delete 5 from this list. Delete first node after nil node. If I run delete first, after that another time, the size of list is 0, nil node dot next node in this time is 13. Okay, the node that has 5 in its element has been removed. Okay, in this way, easily you can have a simple data structure, and you can save your data and your element, each element, integer, character, string, or other things, okay, in your list, and you have a better ordering in your data saving, in saving of your data in memory. Okay, so I have simple linked list, and I can insert a node at the first of this list and delete a node from first of this list after new node. Okay, but to do some practice, implement these operations and function by yourself. Insert after and delete after. You can use this textbook to implement these simple functions, but this function is simple. You can easily implement these functions. Okay, but when you want to insert after a node in your function, for example insert, you need a list, you need a node that you want to add, and a node, for example a node node 1, for example you want to add node after node 1. Okay, in your function you need 3 arguments, and similar that for delete after you need but for delete after you need 2 arguments. Delete, you need list and a node. You want to delete a node after this node. Okay, implement these 2 simple functions by yourself. I will give you some other implementation of linked list in next parts. Okay, and I will walk you through to implement more data structures and advanced data structures in the next parts. Okay, thank you very much to see me, and see you soon in the next part. Thank you very much.